we'll be discussing functions. Functions are composed of two parts, a over b. A is known as the numerator, which is the section that is taken out of the whole, and b is known as the denominator, which represents the whole in itself. Okay, the basic concept concerning functions would be the least common decimal. The least common decimal is also known as the least common multiple when it comes to equivalent functions. For example, as we look at example number 1, it says find the least common multiple of 3 and 8. Well, when we check the multiples of 3, we find that we have 1 and we have 3, as 3 is known as a prime number. Whereas 8, we find that there is 1, there is 2, there is 4, and there is 8. Right. Because of that, these are known as factors. And seeing from the factors, we see that there is no common factor. Therefore, the common multiple will just be 3 times 8. Example 1 asks us to find the least common multiple of 3 and 8. To find the least common multiple of 3 and 8, we need to first look at the factors. So when we check for the factors of 3, we find that it's only 1 and 3 because 3 is a prime number. And when we check the factors of 8, we find that it is 1, 2, 4, and 8. With that said, we look and we compare if there are any common factors so we can get the common multiple. As we can see, there are no common factors, therefore we can say that 3 times 8 is equal to 24, which is the lowest common multiple. When we go to example 2, we are asked to find the least common multiple, or rather the least common denominator. When finding the least common denominator, we take into consideration the denominator itself. And as calculated in example 1, we find that the least common multiple of 3 and 8 is in fact 24. With that said, we get the least common decimal. Steps to consider when finding the least common denominator. Step 1 is to check if the larger denominator is a multiple of the other denominator. Step 2 is to check if one or more of the denominators is a prime number and multiply the denominator to find the lowest common denominator. And lastly, if necessary, find the lowest common multiple of the denominators. We move over to example 3, where we are asked to calculate the least common multiple of each pair of numbers. For A, we have 5 and 7, which both numbers are prime numbers. Therefore, we just multiply the two numbers. For B, we have 7 and 12, and 7 is a prime number, and 12 is 12, 24, 36, 48. Whereas 7 is 7, 14, 21, 28, and so on. Right? And as we go on and go on, we find that 7 and 12 do not have a common multiple. Therefore, we multiply the two to get 84. We carry over to C, which is 4 and 28. Now, we carry over and we go 4, 8, 12, 16, 20, 24, 28. With this said, we know that our lowest common multiple is in itself 28. We carry over and we look at example 4. Example 4 asks us to find the least common decimal for each of the fractions. We know that for A, we know that 3 is a prime number and 7 is a prime number. So therefore, all we do is multiply the two denominators, get 21. With this said, what we do to one fraction, we need to do to another fraction. So we will multiply. So to get a full solution, we need to multiply 2 over 3 with 7 over 7, which is 14 over 21. And we need to multiply 5 over 7 with 3 over 3, which is 15 over 21. You may be asking yourselves, why are we multiplying the 2 with each of each? That is because to get the lowest common denominator, we will need to multiply this denominator with the 7, as it is both prime numbers. Therefore, the 7 needs to be multiplied on both sides of the fraction. So when we multiply, what we do at the bottom, we need to do at the top to get a full fraction. We carry over to 10 and 45. We know that the multiples of 10 do not include 45 because we have 10, 20, 30, 40, 50, where 50 is larger than 45. But we do have 90, 50, 60, 70, 80, 90. Correct? And then 45 is 45 and 90. Therefore, we know that the least common denominator between 10 and 45 is in fact 90. We carry over to example 5, where example 5 asks us to change the fractions into equivalent fractions. Changing fractions into equivalent fractions, we need to know the least common denominator. So, 7 and 5. The least common denominator between 7 and 5, because the two are both prime numbers, will multiply 7 and 5 to get 35. Therefore, we already know the denominator of each, okay? But because we are equivalating the fractions, what we do at the bottom, we do at the top. So, to get 35, we needed to multiply 7 times 5. So therefore, we need to multiply 2 by 5, which will give us 10. As well as 5, we had to multiply it by 7. Therefore, 5 times 7 will give us 35. What we do at the bottom, we do at the top. So 1 times 7 will give us 7. The same rule applies with 2 and 8, but we need to be cautious when we are considering even numbers, because we cannot just multiply them as they are not prime numbers. So therefore, with 2, we have 4, and we have 8. With that said, the lowest common multiple between 2 and 8 will be 8 in itself. So for this one, we do not change anything because 8 was already the denominator of this fraction. But for 2, we need to multiply 2 by 4 to get 8. And what we do at the bottom, we do at the top. So therefore, we multiply 1 by 4 to get 4. And that's how we equivalate the fractions. We go to C. We have 10 and we have 45, correct? And 10 has the multiples 10, 20, 30, 40, 50, 60, 70, 80, and 90. And 45 has the multiples, so we'll just do that. And 45 has the multiples 45, 90. Okay? As we can see, this is the lowest common multiple. If we had to multiply the 2, we would get 450, which is in fact not the lowest common multiple. So what we do is we write down 90 as the denominator because that is certain. And to get 90 from 45, we had to move 2 steps, so we had to multiply by 2, right? So what we do at the bottom, we do at the top. So 7 times 2 will give us 14, right? And same with this, to get 90, we had to move 9 steps, right? So that will be 10 times 9. Therefore, what we do at the bottom, we do at the top. So then it will be 3 times 9, which is 27, okay? And we carry over to D. And it's the same concept. We check 6 and 9. Are they prime numbers? No, they are not. 6 consists of 6, 12, 18, correct? And 9 consists of 9 and 18. With that said, we know that this is the lowest common multiple. Therefore, we know that it will be our lowest common denominator, right? At the bottom, we had to times by 2 to get to 18. At the top, we have to times by 2 to get 14. At the bottom, we had to times by 3 to get to 18. At the top, we need to times by 3 to get 15. As we carry on, we establish 3 fundamental guidelines to follow when comparing fractions. The very first guide is, if the denominators are the same, then we rather look at the numerator. The fraction with the larger numerator is the fraction that is greater than the other fraction. Okay, for example, we have 1 over 20 and we have 10 over 20. 1 over 20 is less than 10 over 20. But 5 over 13 is greater than 2 over 13. Why? The numerator 1 is less than the numerator 10. Therefore, the entire function will be less than this fraction. Okay? And then we look at the second point, which is 5 over 13 and 2 over 13. 5 is greater than 2, therefore the entire fraction is greater than this fraction. Alright? Then, the second point is that if the numerators are the same, then the smaller denominator has the greater value. So it is the reverse of number 1. For example, 2 over 7 is greater than 2 over 20. While this may be confusing to you, so I will furthermore explain an example. So the numerator will be representing the number of apples, okay? So each person, so the numerator is representing the number of apples. We have 2 apples, and the denominator will be representing the number of people, okay? So with the first fraction, we have 2 over 7, right? So if we have 2 apples and 7 people, we need to cut the apple so that it can benefit 7 people, so that each of the people can get a piece of the apple. But for 2 over 20, we have 2 apples and 20 people. So now we need to cut the apple into smaller pieces so that each of the 20 people can get a piece of the apple. Okay, and then we go to our very last point, and it says that if the numerator and the denominator are different, then we find the lowest common denominator. So, for example, we have 7 and we have 2. We have 5 over 7 and we have 3 over 2. So what are we going to do? Because 7 is a prime number, we're going to multiply the 2 to get 14. Because 7 times 2 equals 14. Therefore, what we do at the bottom, we do at the top. So then 7 times 2, 5 times 2 to get 10 over 14. And then for 3 over 2, we multiplied by 7 to get 14. So we have to multiply the top by 7 as well. So then we will have the denominator as 14 and then the numerator. So the numerator will be 21 over 14. Thank you for watching this video, and tune in to the next video explaining mixed fractions.